Hello, everybody. My name's Teacher Daniel, and today we're going to learn about science. What?
Hey, Teacher Daniel. Thanks for having me over to your classroom.
You're welcome.
I like what you did with the place. It looks really cool.
Thank you.
Hey, do you think that we could spruce up the joint a little bit?
I think so.
Okay.
That would be fine.
Well, we've got a bowling ball pin behind us. That's a little fun thing you've got there. And then, wait, what's this over here?
That's a robot.
This?
No, wait, it's a panda robot.
You like pandas too?
Yep.
I love pandas.
And also it has holes.
Yep, because it's a salt shaker.
Salt shaker?
Uh-huh. We're going to need some salt here in a bit. Now, can you tell me what this is?
It's a molecule.
Very good.
It's called a molecule.
And you know what we're going to do today?
What?
We're going to learn how these dissolve in this. What's this called?
Water.
Very good. And we're going to take that water and we're going to add something called salt.
Salt is really cool.
Okay?
It's so soft.
That's right. And this soft salt is going to go into that water.
Ooh. And
we're going to mix them up and see what happens. Okay? Are you excited to learn?
Yeah!
Let's go!
Yeah!
Okay, time to pick up where we left off on Tuesday. So, Tuesday, you would have remembered this. That if you have a solute and you add it to a solvent, you're going to make a solution. Now, the simplest example from some of those videos that I posted on Tuesday would have been something like this, where we take salt and we add it to water. That's your solute added to your solvent. Mix those together and you've got a nice solution. But there's a couple of things we need to talk about when we talk about a solution. We need to know more about it, especially in chemistry. And the things that we're going to talk about today are going to be how concentrated is that solution? How much of the solute is actually mixed into the solvent? Because as we know, if I have this much water and I keep it at this level, at my 350 milliliter level, and I add this amount of salt, or twice as much salt, or 4 times as much salt, it's going to become more and more and more concentrate. So the concentration of a solution, not like how much you're thinking about something or how hard you're focused, no, how concentrated it is, how much of the solute is in the solvent. Because it can be really, really low concentrations, or it can be really, really high concentrations. And that's going to affect a lot of things in chemistry. So we're going to learn how to calculate that today. And a big word you're going to hear me say is molarity. Molarity. Starting with moles there, that's right. Remember, moles is the amount of anything. You can have a mole of water molecules. You can have a mole of salt molecules. But molarity, in this faction, what we're talking about is how much stuff, how much solute is in the solvent. So the molarity of a concentration is how concentrate that substance, or not concentrate it is. And that's what we're going to focus on today. So if we're going to break down solutions, concentrations, and molarity, we're going to start with just talking about water and salt today. And that's it. And from there, hopefully, you'll get the gist. Okay. So let's talk about water and let's talk about salt. To figure out where we're going to need to head today, we need to figure out the molar mass of both of these. So let's start by simply calculating that. I know we already know how to do this, but here's a simple quick review. Remember, for molar mass of water here, we want to look at the hydrogen, which has 2 atoms of it. And we're going to multiply that by the molar mass, which is the atomic mass of hydrogen, which is 1.008. I'm just going to call it 1.0 grams per mole. Okay? And we're going to look at oxygen. Oxygen has only 1 atom of it right here. So we're going to multiply that by 15.99. I'm going to round it up to 16 so that everybody understands what's going on here. I'm just rounding, make the numbers nice and easy. 16 grams per mole. Now, all you got to do to figure out the molar mass is simply add those up. So I've got 2 times 1 is 2, plus 1 times 16 is 16. So 2 and 16, we've got 18. That's a little about 18 grams per mole. So we now know if I have 18 grams of water, that is equal to 1 mole of water. All right? So that's our water on one side. Now let's cut over and check out salt. Now we're going to go through the process with salt. So we need to find the molar mass of salt. This one, fortunately, is pretty easy because there's only one atom of each. But get out your periodic tables and follow along with me. Now, the first thing we're going to do is look up sodium on the periodic table. You're right here. And then we're going to look up chlorine, slide over to number 17, and you're right here. Now, sodium, Na, has only one atom of it. I'm keeping the form the same here, by the way, just so that I get in good practice, so that you hopefully can get in good practice for doing this every time you work the molar mass of something. So if I've got one atom of sodium, and sodium weighs 22.99, again, let's round that up to 23 grams per mole. I'm going to now look at chlorine. And chlorine, again, there's only one atom of it. I'm going to multiply that by chlorine's atomic mass, which is its molar mass, 35.45. We can go ahead and say 35.5 grams per mole. Now that we have that, we can simply add the two together. Now, really quickly, so we've got 58.5. And that's about grams per mole. This is equal to 1 mole of salt. So if I had 58.5 grams of salt, I would have 1 mole of salt. This is stuff we've already done before. Now let's figure out how we can use this to figure out the concentration and, more importantly, the molarity of a solution. Now that we know the molar mass of our salt, it's time to start figuring out some basic problems. Like I said, the best thing to do with this stuff is to dive right in. So let's get going. And this is the interactive fun part where you get to write along things with me. We're going to solve a problem. Now, the problem I have today is going to be how concentrate a certain volume of water with salt in it. So the solution of salt water, we're going to figure out how concentrated it is. Now, to do that, we're going to need a quick little formula. And here it goes. Definitely write this down. So, molarity is equal, wait for it, to the moles of solute divided by the liters of solution. So, molarity again. This guy. This is what we're looking for. This is what concentration means in chemistry. How many moles of that stuff do you have? Remember, the moles of solute. That would be our salt right here. Moles of salt, in our case, divided by the liters of solution. Now, the solution in this case, remember, the solute plus a solvent equals the solution. So salt plus water makes salt water. So what we're trying to find out is how much salt is there in all of the salt water? So this solution over here is the salt water, the end result. And we're going to take a quick look at a problem. So make sure you're writing this down to solve for what we're going to be looking at next. Here comes the problem. Consider that you are given 350 milliliters of salt water. So you've been handed a 350 milliliter bottle of salt water. It's already pre-made. The solution is there. What is the molarity of the salt water if 29.25 grams of salt are used to make it? So just a shy under 30 grams of salt, just 30 grams of salt, are tossed into that water, shaken and mixed until it's completely gone into solution, and I want to know what the molarity of that salt water is. How much salt is in that water? Let's use the equation that I just gave you to figure it out. So, now that you know what the problem is, let's take a look at what that actually looks like. We've got this test tube, which is filled with 29.25 grams of salt. And on this side, we have 350 milliliters of salt water. So, a couple of issues here. When you go back and look at that formula you just wrote down, number one is that it was given to you in liters of solution, not milliliters. So you're going to have to pay attention and convert that unit. It's a simple conversion to go from milli all the way back up to liters. You simply move the decimal places 3 places back from 0 to 3. So 350 milliliters is actually equal to 0.35 liters. All right, that part's done. We'll write it down in a second. The other issue is that we have grams of salt. Now, this is the biggest issue because grams of salt has no correlation to moles, and that's what we need it in. We need moles of solute, not grams of solute. So my scale doesn't help me out with that. It doesn't tell me moles. So I've got to convert from grams to moles. The best way to do that? That's right, the molar mass. Let's get busy on paper and I'll show you what I mean. So here's the facts that we start off knowing. Previously, we already calculated the molar mass of salt. Now what we need to consider is what the problem gave us. We start with the problem telling us that we have 29.25 grams of salt. There we go. NaCl, not Cl. So 29.25 grams of salt is what we have, and we want to know how many moles that is. Now, the great thing about this is that we have the molar mass. The reason why this is so important is because the molar mass is units. Check it out. They have both grams and moles in them. And I want to get from grams to moles. So here's how you set the problem up. Start with what you know. I gave you 29.25 grams of salt. That's what we're going to start with. Now, to think about that, we're going to go back to doing a little bit of multiplying by fractions here. So I'm going to say that 29.25 grams of salt is the same as saying 29.25 grams over 1. Agreed? Agreed. Now, we're going to multiply this by another fraction. But that fraction is going to be made up of the molar mass. Now, if I multiplied it by the molar mass, it'd be 58.5 grams. Grams times grams doesn't help me. I want to cancel grams. So I'm going to put grams on the bottom, and I'm going to put moles on the top. All I did was take these units and flip them, which instead, now I need to flip the number. So 58.5 grams goes here, and now 1 goes here. Now when we plug this into our calculator, all we need to do is say that 29.25, because it's multiplied right here, what we're really saying is divided by, because it's on the denominator side, 58.5, and we get this awesome number here, 0.5. This is equal to half of a mole, 0.5 moles of salt. Now, if you're looking at this all together, you probably figured out that when I gave you the problem, all I said was, let's just see what half of a mole is. So I simply divided this number in half. But when we work it back, if you take 58.5 and divide it by 2, that's right, you get 29.25 grams. That's how I came up with this number. I could have picked any number here, but here's how you convert it to moles. You take it and you multiply it by flipping the molar mass. But there's a much nicer way to think about how to do this problem. Okay? Let's take a look at that. If you look at what I like to say is my gram box, whatever number I give you here in homework, I might give you grams of something, okay? Whatever that number is, you want to move it over to the mole box. Now, to do that, to get from grams to moles, here's the trick. All you need to do is divide by the molar mass. But here's the really cool thing. Because those units for molar mass up here are grams to moles, moles to grams, we can do the same thing. What if I gave you a problem where I gave you moles and I asked you how many grams there were? Here's the cool trick. To go back, you simply, to get to this, multiply by the molar mass. How about that? So, what's going to be key for you and your homework is that you know that you are going to get from grams to moles by dividing by the molar mass. And that is exactly what we did here, now minus all the speckles, but what we did here to get from 29.25 grams of salt to moles of salt, we divided by the molar mass. So the steps that we just went through were pretty important. What we now know is that 29.25 grams of salt is actually 1/2 of a mole of salt. So 0.5 moles is what we're really looking at here, just a half a mole of salt. The next step's the last one, and the answer to the question that we've been looking for. What's the molarity of this much salt in that much water? Let's go on and solve for that next. So here's what we were given. We were given 350 milliliters of salt water. Now remember, that is the solution. And we were also given 29.25 grams of salt. What did we discover that we needed? Well, remember, molarity is equal to moles of solute divided by liters of solution. So with this formula in mind and this information given in the problem, we had to fix two things. Number one was the water, the salt water itself. It was given in milliliters. We needed to convert that to liters. So down here, this is where we put our liters of solution. That's the salt water. So we converted 350 milliliters by sliding our decimal place back 3 places. We made it to liters. So that's really 0.350 liters of salt water. Here we are here. Now, we were looking for the molarity. Now, up top, we needed moles of solute. We were given 29.25 grams of salt. Now, we worked together to convert that to 0.5 moles of salt. And this, remember, is our solute. So, all we need to do now is to take 0.5 and put it in the numerator and simply do our calculation. Now, when we sit here and look at our calculation, we can say 0.5 and divide it by 0.350. When we hit enter, we get our molarity. The molarity is equal to 1.4 molarity. This is a capital M. This is the unit we're going to be using for molarity. So, molarity, capital M. Not to be confused with moles, which we shorten to MOL. Just like that. And this is how you're going to work your homework tonight. I'm going to be giving you problems that ask you to solve for molarity. Now, you've got to pay attention to what units I give you. So if I give you grams of a substance, you need to convert it to moles of a substance. And make sure you're paying attention that if I give you milliliters, you're going to convert to liters. Okay, I hope that this molarity lesson has made a lot of sense. I hope that you now know how to convert grams to moles and even moles to grams if you have to. But more importantly, I hope you understand the whole purpose is to figure out this problem right here. And to help me with that, I've brought in an expert. Professor Daniel, how are you doing today?
Good.
Yeah? So, Daniel,
What?
Sorry, Dr. Daniel, do you know about moles?
No. I don't know about that.
Well, do you know about concentration?
Yeah.
Okay. Do you know about solutions?
No.
Do you know about this?
No.
Well, I know people that do know all about that stuff. Guess who they are?
Who?
Right there, those kids.
Oh.
Pretty impressive, huh? They're pretty smart. And guess what?
What?
I think after you watch this video, you'll understand what moles, concentrations, and solutions are too. What do you think?
Oh yeah.
Oh, yeah. Well, why don't you tell them what you always tell them?
Thumbs up if you love this video so much.
Perfect.
Hello everybody. So you know I these Hello Kids, and so these are rainbow bridges, and when they get up to each other, they connect and make a rainbow bridge. So I hope you have fun making them at home too. And thumbs up if you love this video.
Testing, testing. 1, 2, 3. Science, here we go. Let's wait and see.